So hey guys, this is Biswajit and welcome to my YouTube channel. So in this video, I'm going to explain about categorical encoding in pandas in machine learning. So basically, there are two types of encoding you can use for categorical attributes. So I know two types of encoding. So there is something known as one-hot encoding and there is something known as level encoding. So people generally go with one-hot encoding. There are obvious reasons for that, and very few people go with level encoding. Like it's a different scenario case. So why one-hot encoding and why not level encoding? So generally in level encoding, the encoding is done in forms of like sequence. Like for A, it will assign as 1. For B, it will assign as 2. So there is a 1, 2, 3 sequence that happens. Like for example, for A, it assigns 1. For B, it assigns 2. For C, it assigns 3. What the algorithm thinks is A into 2 equals B. Okay. And B into maybe 1.5 equal to C. This is what it thinks, like, because these are numbers, right? So this is what the algorithm thinks. Like there is some sort of a dependency. Now the fun part is this can be dog, this can be cat, and this can be something known as let me take a sheep. Okay, so now just replace this equation with dog dog into 2 equal to cat. Now, does this really make any kind of a sense? No, right? So this is where level encoding, like we're not supposed to do level encoding at all. So in most of the cases, I go for one-hot encoding. Now, where we should use level encoding is used when we are showcasing something known as junior, something known as senior, something known as maybe a PhD guy. Now, this makes some sort of sense because there is some sort of ranking. Okay. But in this cat dog scenario, this does not make any sense. So I'm going to explain both of this, okay, part by part in different videos. First of all, let's talk about one-hot encoding, why it is used and how it works. So for example, if there are like categories, okay, many categories. For example, if there are three categories, okay, and if there is a data known as A, this means as 1, 0, 0. If there is a data known as B, this means as 0, 1, 0. Okay, this is how the encoding happens. Okay, this is how it happens. This is one-hot encoding. Pretty simple to understand and use. This is 0, 0, 1. Okay, so this is what one-hot encoding means. So if there is a data known as C, it is going to create 3 columns with 0, 0, 1 as the values. Okay, so let me showcase using code ls Titanic.pd. Okay, I have to import pandas as pd. This is the data, right? Now let me select a good category, embarked. Okay, Titanic of embarked is the column that I selected. Let me change this from a series to a data frame. This is the one that I selected. Now, I don't know whether I should handle null values or not. I am directly go with the encoding process. So this is a categorical data. So now machines cannot understand this. This is a string data, right? So machines cannot understand this string data. So you have to convert this into some sort of value, right? So there are only two ways to do it. Either you convert this into something known as a level encoder or something known as a one-hot encoder. So now this is nothing but this is a string value. Okay. So you need to convert this to a number. So generally I'm gonna go with one hot encoding because that is what this video is all about. But you can also see there are many numerical values. For example, survive 0, 1, 0, 1. 0 means they didn't survive, and 1 means they survived. Okay. So this is 0, 1, 0, 1. This is a categorical data. Okay. This is categorical data. This is not a numerical data. These are represented as numbers, but they are categories. Okay. So now, even in this case, also you have to go with one hot encoding or level encoding. Okay, because this is already like this data is already distinguished like 0, 0, 1, 0, 1, 0, 1. So if you don't want, you don't need to go for encoding also. This will simply gonna work because these are already numbers. But if you want, you can go with categorical encoding or one hot encoding, because if you look carefully, the 0, 1, 0, 1, it's sort of already it's sort of an example of label encoding. Okay, but you can also go with one hot encoding also, no issues, because I just noticed it. um Titanic, Titanic embarked. Now for example, this is the column which I am interested on. Now I want to do one hot encoding on this. So to do that, from sklearn dot reprocessing, hopefully it is present over here, import one hot encoder. Yes, simple. I just do encoder equal to one hot encoder. All right. Now, if I do encoder dot, there are fit and transform. I already spoke about this fit and transform. If you have not checked, go and check my fit and transform video. Okay. So I'm just gonna go with fit and transform, and I'm just gonna pass this data frame here, and it's going to return me a sparse matrix. Okay, it is returning me a sparse matrix with 4 columns. Let me check the first value of it. Okay, it's not allowing me. Let me forcefully do it. Import numpy as np. Do I require this? Maybe to array. Yeah, no, I don't. I didn't require numpy of 0. Okay. So it is creating, it created 4 columns. Okay, why did it create 4 columns? Let me find it out. So for example, Titanic embarked, if I do dot value counts. Okay. Okay, so there is S, and there is C, and there is Q, and I think there is a null value also. So for that, it created this 4 column. Let me handle the null values also. There are null values because I have shown you in the previous video. There are null values for which it is creating 4 columns. It's supposed to create 3 columns. See, there are null values. Now let's handle this null value. So Titanic embarked. Now how I'm gonna fill it? Let me do it very simply. Dot fill na with value. I think value as capital S, and I'm gonna do in place as true. Okay. Okay. Fine. If I do this, this is a warning. We'll talk about this later. Now, if I check whether I have already handled my missing values or not, okay, I've still not handled. Let me deal with this properly. Okay, so I am not going to do in plus equal to true. So this is the new value. Let me assign that to my data frame directly. It needs this. This is the way to do it. Now, if I execute this, okay, that those null values got handled. Now, if I do dot na dot sum again, so you can see there is nothing. So there are no null values. So previously there was 2 null values. I handled it over here, and now there are no null values. Okay. So now if I do one hot encoder again, it should give me 3 columns only. And yes, it is giving me 3 columns only. This is what I was talking about. So it gave me 3 columns, one for S, one for C, one for Q. This is S, C, Q. Let's verify the data, how the data looks like. Okay. So first one is S, second one is C, and I think we have Q. Okay. So maybe it has arranged this in this fashion. Maybe it has arranged this somewhat like maybe C and Q and S. Okay, alphabetical order. So this is S, right? So first one is S. So it has arranged, it has made this as 0 because this belongs to C. And second one also is 0 because this belongs to Q. And third one is 1. So this is S. Okay. Let's check for the second row. And it should give me 0. It should give me 1, 0, 0. Yes, 1, 0, 0. Okay. So this value is C. So first one is for C. That's why I'm getting as 1. I mean, first value is C. Second one is Q. And the last one is S. Okay. This is Q. Okay. 890. Let me give 890, 890. So it should give me a value of 0, 1, 0. Right. 0, 1, 0. Okay. So these are like the places, they are connected to each other. Like for the first index, it is C. For the second index, it is Q. For the third index, it is S. Okay. So this is the for this index 890, the data is Q. So this belongs to C. C is not Q, so it's 0. Q is Q, so it's 1. Q is S, so it's 0. Okay. So this is one hot encoding, right? So this is how one hot encoding works. It's pretty simple. I hope I was able to explain you, and I was able to show and verify the data how this encoding actually worked over here. Okay. So this is the data actually it gave us a sparse matrix. Okay. So sparse matrix is like a little bit efficient version of a normal matrix. So what happens in a sparse matrix? Generally, if you look carefully, if I do to array, you will see most of the data over here are filled with zeros. Most of it are filled with zeros. So what Python does, what Python does, it just remembers the position where we have 1 as the value. Okay, where we have 1 as the value, and it just don't remembers these zeros. So what happens? It remembers the value for 1 over on here on the third place, here on the first place, here on the third place. This is how it is able to manage memory faster. So now it gave us a sparse matrix. This is how we are going to work with. So this is how one hot encoding works in categorical value. If you are able to understand it, so give a like, and thanks for watching this video. We'll see you in the next video.